Hello, and welcome again to the second installation of how to perform factor label conversions. This time specifically, instead of discussing one-dimensional conversions that have one-dimensional units such as meters or feet or inches, instead we're going to discuss two-dimensional conversions. What you do when you have, say, an area measured in square feet that you'd like to convert to square centimeters. Or perhaps we're talking about a volume of space, which is three dimensions. A length, a width, and a height multiplied together actually give you cubic units of feet, cubic units of meters, for instance. So, how do we do this kind of conversion? Well, it's not too great an extension from the conversions that we have been doing before on one dimension. The only difference is this, an understanding. Let's say we had about a foot, which was 12 inches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we were to multiply this 12 square by 12 square. We want a square foot by a square foot. Well, we'd have to draw 12 lines this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if you were to count up all the squares here, in other words, how many square inches you have in this diagram, you're going to have 12 inches by 12 inches, or literally 12 squared inches squared. In other words, you're going to see 144 square inches in this grid that's 12 inches by 12 inches. In other words, short way of saying this is if I know a conversion in one dimension, namely that 1 foot is equivalent to 12 inches. Well, if that's true in one dimension, then all I need to do is square both this side and this side of the equation, and I still have an equation. 1 squared is merely 1. Feet times feet is feet squared. 12 times 12 is 144, or 12 squared. And inches times inches is inches squared. In other words, if 1 foot equals 12 inches in one dimension, then 1 square foot equals 144 square inches in a two-dimensional area. And I could use this as a conversion factor for a two-dimensional conversion, just as I could use this for a one-dimensional conversion. Examples, therefore. Let's say that we wish to convert 12.0 feet squared to units of metric units. Let's go micrometers squared. Well, I have the same dilemma that I had when I was working in one dimension. First, I have to identify what system I'm using. I'm given a measurement in the British system of feet, but I want units that are in the metric system. Therefore, I'm going to need to bridge the two systems with an understanding, or a dimension, an equation that I know. And in one dimension, we learned last time that 1 inch equals 2.54 centimeters. So if that's true, I can square both of these and get an equation for square inches to square centimeters. 1 inch squared is what I get when I square this. And 6.45 centimeters squared is what you get if you square 2.54 and then square the centimeters. So you see, this would be my bridge between metric and British and metric, if I'm doing square dimensional analysis. So my first goal then would be to get to my bridge. I need to convert square feet to square inches so that I can bridge to the metric system. Not very difficult. Namely, I'm going to write the units in first, always. Feet squared, inches squared, because again, I'm trying to cancel feet squared and replace it with inches squared. Think in one dimension. In one dimension, 1 foot is 12 inches. but simply square the dimensions because we're squaring the units. 1 squared is still squared. 12 squared is 144. And I may choose to either write it that way so I can visualize it, or I could write it as 12 squared. However, when you go to do the calculation, you have to remember you're going to take 12 and then you're going to multiply it by 12 squared. That will have to be part of your calculation if you choose to write it this way instead of actually performing the squaring calculation before you write your conversion factor. Either way, your feet squared cancel. Now you have inches squared, and you can bridge the gap between British and metric. Writing the units first. Our bridge exists between inches and centimeters in one dimension, so the bridge works in 2 dimensions as well. And yes, in 1 dimension, one of these equals 2.54 centimeters. But I have to remember to square that value. The inches squared cancel. And we're almost there. Now, we did want micrometers squared, and I recommend that when you're working through the metric system, if you go from one prefixed unit to another prefixed unit, always go through the base unit first in 2 steps. So my first goal would be to convert centimeters squared to meters squared. Write the units first. Visualize the cancellation process. Then go ahead and think of the values. Well, 1 prefixed centimeter, centi means 10 to the negative 2. So I could write this as 10 to the negative 2 meters all squared, or if I'm good with powers of 10, I might want to do that in my head first. A power raised to another power, I would multiply the exponents. 10 to the negative 4th. That's the same as writing 10 to the negative 2 squared. However, whichever way you do it is your choice, whatever you're most comfortable with. Either way, the centimeters squared cancel, and now I'm ready to make my final conversion to the micrometers. Namely, I would write meters squared in the denominator to get cancellation, micrometers squared in the numerator to leave me with the units that I want in 1 dimension. 1 micro means 10 to the negative 6th of something, but since we're squaring the units, we must also square the values. Once again, I could choose to write this as 10 to the negative 6 all squared, or I could do that calculation in my head and write it as 10 to the negative 12. They have the same meaning. Nevertheless, everything has now canceled with the exception of micrometers squared units, which is what I wanted. So I grab my calculator, multiply 12 times 12 squared, or 144, times 2.54 squared, or 6.45, times 10 to the negative 4th, and finally divide by 10 to the negative 12. Your calculator will read something like 1.8580608 times 10 to the 11th. Big number. But then again, we're talking about square feet and shrinking it down to square millionths of a meter. So I should have a large number. But 2 things wrong with my answer. First being, these are all exact measurements, but this is a measured number with 3 digits. So I would want 3 digits in my answer. 1.86 times 10 to the 11th. And lastly, never forget your units. Micrometers squared. And that would be the correct conversion from feet squared to micrometers squared. Now, as a second example, if this all works in 2 dimensions, there's absolutely no reason why it wouldn't work in 3 dimensions. For instance, what if I had the valued measurement of kilometers cubed, 3.0 kilometers cubed? Now that's quite a large volume of space. Imagine something that's 1 kilometer long, 1 kilometer high, and 1 kilometer wide. That would be a cubic kilometer of space, a very large volume of space. Nevertheless, I'd still like to be able to convert it to other units. Let's say, I don't know, How about nanometers cubed? Tiny little units. Once again, I'm expecting a whole lot of them. After all, I'm going from cubic meters, large space, kilometers even, 1,000 times that big, to cubic nanometers, things I couldn't even see, they're so small. So I'm expecting to get a large number. Nevertheless, I do the same thing. I think in one dimension about relationships, but now if I'm cubing the units, I cube the dimensions. I'm going from a prefixed unit, kilometers cubed, to another prefixed unit, nanometers cubed, so it makes sense to do it in 2 steps. Go from the prefixed unit to the base unit, which would be meters cubed from kilometers cubed. And then I think about one dimension and cube the values that go with that dimension. So yes, 1 kilo of anything is 10 to the third of something, like meters. But if I'm cubing the meters, for this to still equal numerator and denominator, I must cube the 10 to the third. So yes, a cubic kilometer is the same as 10 to the third cubed meters cubed. Or if you prefer, 3 times 3 is 9, 10 to the 9th cube. Both are equally correct. Both will get you the right answer. Kilometers cubed cancel. I then can make the final conversion to nanometers cubed, which is what I want. I think in one dimension. 1 nano of anything, including meters, is a billionth, 10 to the negative 9th of something. But that's in one dimension, and I am cubing these dimensions. So yes, 1 tiny, tiny little cubic nanometer is equivalent to either 10 to the negative 9th cubed, or negative 9 times 3 is 10 to the negative 27th cubic meters. Both are equally correct to do. However, if I write it as 10 to the negative 9th cubed, when I divide, I want to be sure to do that calculation. Namely, divide by 10 exponent negative 9, all raised to the 3rd power. Nevertheless, however I choose to do it mathematically, or what I choose to write, I see that my relationships, equivalents, are all true in cubic units. I simply grab my calculator and multiply 3 times 10 to the 9th, and I divide by 10 to the negative 27th, and my calculator gives me a very large value indeed. 3.0 times 10 to the 36th, that's awfully large, nanometers cubed. But I was expecting that. I'm picturing something that takes up more space than about 4 or 5 superdomes. I'm talking about how many tiny, tiny, tiny little cubic billionths of a meter would fit into that space. And it's going to be a significant number. In any event, the digits are correct because this is the only measured number on the board. So 2 digits, 2 digits. I have the correct units. I've made a successful conversion. And you may be wondering, how does this apply to chemistry? Because after all, chemistry is the study of matter. And matter, by definition, is anything that has a mass and takes up a volume of space. Well, we're going to study volumes an awful lot in chemistry and work with volumes plenty of times. So, of course, being able to convert between units of volumes is very important. Now, the interesting thing is, and this is where it gets fun, there are really 2 types of volumes that we make measurements with. One type is the sort of measurements we make for fluid volumes. Namely, if I wanted to go down to the store and grab some milk, a fluid, I would talk about one-dimensional units as volumes. For instance, in the British system, the gallon is how we measure fluid volumes. I pick up a gallon of milk. Definitely that's 3-dimensional, but a fluid volume unit is 1-dimensional. The equivalent in the metric system would be, of course, the liter, if I picked up a liter of something. Now, if we're going to convert between fluid British metrics, we need a conversion link, a bridge across the metric and British chasm. And the one I like to use is this one right here. Namely, a liter is a little bit less or a little bit more than a quarter of a gallon. If I have 1 gallon, I have almost 4 liters, 3.785. So yes, we're going to use that anytime we need to make fluid conversions between British and metric. However, how do we equate that with the fact we could also express volumes in cubic units like we did in the last problem? For instance, we could talk about cubic feet. We could talk about cubic millimeters. And how do we convert these to fluid volumes if we wish, or vice versa? We have a fluid volume. We'd like to say how many cubic feet it is. Let's say I have a big 50-gallon drum, and I want to know how many cubic feet or cubic inches of space all that liquid would occupy. Well, you need to know one other important fact for that conversion, and that is that 1,000th of a liter, 1 milliliter, and this is a fluid volume. This is a one-dimensional unit. It is not cubed. There's no such thing as a cubic gallon, a cubic liter, a cubic milliliter. But one of these one-dimensional fluid units equals, by definition, a cubic centimeter, which is, of course, a three-dimensional length. 1/100th of a meter by 1/100th of a meter by 1/100th of a meter. And this is a critical link between one-dimensional fluid volumes and three-dimensional volumes of space. It allows me to convert back and forth between the two. So sometimes I have to worry about both converting fluid to three-dimensional, I need this, and sometimes from fluid British to metric in fluid volume. So the point here being, the only connection I have between one-dimensional fluid and three-dimensional measurement of volume is through this link. So if I'm dealing with these one-dimensional volumes, either metric or British, I've got to get to milliliters if I'm going to get cubic units. Conversely, if I'm given cubic units, cubic feet, cubic miles, I want to know how many gallons there are in the entire ocean that is so many billions and billions of cubic miles of water. Well, I would still need to go from the cubed units to the fluid units, and I'd have to first convert those cubic kilometers to cubic centimeters and make the jump. Then I could start working and ultimately arrive at gallons. As an example, if I had 2 gallons of some liquid, and I instead wanted to know, say, how many cubic meters that is. Now, 2 gallons is not a lot. I can visualize that. And a cubic meter is quite large. So I'm only expecting to get a fraction of a cubic meter in the space occupied by 2 gallons. And in this case, it's often nice to take pause and think about what you need to do. This is a fluid volume. This is a three-dimensional volume. I am going to need to use this link to get from fluid to three-dimensional volumes. Also, this is a British unit, and my link from metric to three-dimensional fluid to three-dimensional is through the metric system. So now I'm organized in my mind. I realize the first thing I have to do is get this fluid volume to a metric fluid volume so that I can use this relationship to get me to a three-dimensional volume. So, first of all, I need to get gallons to metric fluid volumes. And I'm already at the link. I'm already at the bridge between the two because we know a relationship between gallons and liters. 1 gallon British equals 3.785 liters metric. The gallons are set up to cancel. Now, I realize my link from fluid to three-dimension is through milliliters, thousandths of a liter, so now I need to make one other conversion, from liters to thousandths of a liter. Write the units in first, always. Observe that you can cancel, and then go ahead and worry about the values. 1,000th of a liter equals 1,000th of a liter, and I get cancellation. I'm now all set to go from one-dimensional fluid volume to three-dimensional volume. And yes, 1 milliliter equals 1 centimeter cubed. Everything's canceled, and now I'm dealing with three-dimensional volumes. Now, I want to get ultimately to meters cubed. That's the base unit. And I have a prefix unit, so I need only one more step. But be careful in the step. I don't cube one-dimensional units in conversion. But now all my one-dimensional units are canceled. All I'm dealing with now are three dimensions. So if I want to convert cubic centimeters to cubic meters, think in one dimension. 1 centimeter is a 100th, or 10 to the negative 2 of a meter. But I have to cube these relationships. Notice I haven't had to do that until this point, because all the units I had until I made this conversion from fluid to three dimensions were one-dimensional units. But as soon as I get to three-dimensional units, if I want to cancel them, I have to think three-dimensional units. This is also known as 10 to the negative 6th, if you want to save some time in calculation. The centimeters cubed will cancel, and then I grab my calculator and multiply 2.0 times 3.785. I would divide by second function exponent -3, or divide by 10 to the negative third, and I would multiply by 10 to the negative 6. And if I did so, my calculator would read 7.57 times 10 to the negative third. Not quite the correct answer yet, because we always worry about digits and units. This is exact, this is exact, this is exact. This is a measured conversion between these two systems. So it's not an exact number, the 3.785. It has 4 significant digits. However, my initial measurement, 2 gallons, has 2 significant digits. 2 is fewer than 4. I want 2 in my answer. 7.6 times 10 to the negative third. And most importantly, the units are meters cubed. And that is how I make 2- and 3-dimensional conversions. I'm doing the same thing that I did with one-dimensional conversions. However, I am squaring or cubing the relationships as I go along. Same thing otherwise. And next time when I talk to you, we'll discuss how to work with multi-dimensional units.